right, lesson 8.3, we're talking about solving equations using quadratic methods. Those quadratic methods are what we've been talking about. So factoring, completing the square, using the square root property, the quadratic formula, and then we kind of briefly talked about graphing, which we'll get into more detail later. So looking at equations that are quadratic, so for example, what we were looking at in the last couple of sections are quadratic equations that have an x squared, right? And what we were doing is we would set them up either equal to 0 and then set it up from there to complete the square or to use the quadratic formula. So now what we're going to look at is equations that we can use the same steps, but they don't look exactly the same. For example, this one here, example 1. So notice if we're looking at the exponents here, x is raised to the first power and this one is raised to the 1/2 power. So it looks kind of like a quadratic if x was, let's call it y squared, okay? Then we could rewrite this as y squared minus y minus 6 equals 0. Because if x is y squared, then the square root of x is y, okay? So we're looking at this. It could be rewritten as a quadratic equation, but it doesn't have a degree 2 from the get-go. So using that substitution that we've seen before in order to write this into a quadratic equation that we can solve. From here, we have our choice. We can complete the square, we can see if it factors, or we can use the quadratic formula. The first step, because it would be the easiest route, is to see if it factors. So 6, and it's a -6 and a -1. Well, 6 factors into 3 and 2 to make it negative. The 3 would have to be negative. So I can rewrite this as y minus 3 times y plus 2 equals 0, and we can double check. That's y squared minus y minus 6 by foiling, so it works out. And then remember our zero product property, or the zero factor property, which says that if I have two numbers that multiply to 0, then one of them must be 0. So y minus 3 is 0, or y plus 2 is 0. And then finally isolating y, so that y is 3 or y is -2. Okay, now we got values for y, but we need them to be values for x. So we can rewrite this, and we can say that the square root of x is 3, and then using the power rule, square both sides, x is 9. But remember, we use the power rule, so we'll need to check that. And similarly, the square root of x is -2, square, square, so x is 4. And then we check. So let's check x being 9 first. 9 minus the square root of 9 minus 6, does it equal 0? 9 minus 3 minus 6, does it equal 0? Well, 9 minus 3 is 6 minus 6, so 0 equals 0. That one works. And then we have if x is 4. So we have 4 minus the square root of 4 minus 6. Does it equal 0? 4 minus 2 minus 6, does it equal 0? Well, no, because 4 minus 2 would be 2, minus 6 is -4, does not equal 0. So that means only 9 works. All right, in the second example here, we're also looking at a rational expression equation, so a rational equation, and we want to see how this works out to lead to something that's quadratic. So looking at this, I have fractions, so I know that I need to use the LCD in order to simplify this. Well, the LCD is x times the quantity x minus 2. I have a factor of x minus 2 in the first denominator and a factor of x in the second denominator. And then in the third denominator, a factor of x and x minus 2. So this is my LCD. Now, when we were talking about equations, we said we can multiply both sides by the LCD, and then it would no longer be equations. So we're going to go ahead and multiply the whole thing by x times x minus 2, which means distributing that to each term. And then just like we saw in the previous chapter, the x minus 2's will cancel out. So I get 3x times x minus, the factors of x will cancel out. So x plus 1 times x minus 2 equals, and then both factors in our LCD cancel out for our last one, so we get 6. So we have 3x squared minus, and then we have to FOIL this, so x squared minus 2x plus x minus 2 equals 6. Simplifying, 3x squared minus x squared minus x minus 2 equals 6. And then distributing that negative, I'm subtracting the whole polynomial. So if I distribute the negative, I have 3x squared minus x squared plus x plus 2 equals 6. And then we want to get this into the form where we can solve. So I'm going to combine like terms and subtract 6. So I have 3 minus 1 is 2x squared plus x minus 4 equals 0. So finally we've gotten down to our quadratic form, and now we're going to solve this using the methods that we've seen in the last few sections. Okay, now completing the square, I'd have to divide by 2 and I would get a fraction. It doesn't factor because I would have negative 8, which doesn't have any factors with a difference of 1. So we're going to use the quadratic formula. A is 2, B is 1, C is negative 4, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we get negative 1 plus or minus the square root of 1 squared minus 4 times 2 is 8 times negative 4 is plus 32. Divided by 2 times 2 is 4. So then we have negative 1 plus or minus the square root of 33 divided by 4. My radical is as simplified as it can be, 3 times 11, so no common factors there. And I can't simplify any factors out of my numerator or denominator. So x has the values negative 1 plus or minus the square root of 33 over 4. Now remember, this is 2 values, so I'm going to put the little set brackets to remind you that there are 2 values, but you would not put set brackets in Math Excel. Okay, and then example 3 is similar to example 1 in that this equation is not truly quadratic because it would be to the 4th power, but we can think of it as quadratic if we substitute x for p squared, which means that x squared would be p to the 4th. So if I'm looking at p to the 4th, I replace that with x squared minus 3x minus 4 equals 0. Now that's quadratic. So again, seeing that if I take the middle term has a degree 2 and the highest term has a degree 4, and 4 is twice 2. And when we were looking at example 1, we said the middle term had a degree 1/2 and the highest term had a degree of 1, and 1 is 2 times 1/2. So 4 is 2 times 2, and that's how we can say this is quadratic in form. It's not truly quadratic, but it's pretty close. It has the same properties. Okay, so then solving this one, let's see if it factors. So I have negative 4 in the top, negative 3 in the bottom. So 4 times 1, negative 4 and 1. I think that should work. So we get x minus 4 times x plus 1 is 0. Double check, x squared minus 3, or minus 4 plus 1 is negative 3, and then minus 4. So x minus 4 is 0, x plus 1 is 0, x is 4, x is negative 1. But remember, we weren't solving for x, we're solving for p, so we have to substitute that back in. So we can say that p squared is 4, and p squared is negative 1. And then using the square root property with the plus or minus, p is plus or minus 2. And then same thing here, plus or minus. P is plus or minus I. So we actually have 4 answers here. And we didn't use the power rule, so we don't have to substitute these back in. But notice the degree here was 4, and we ended up with 4 answers. Whatever the degree of our equation is, and we've mentioned this before, that's the most number of solutions we could have. So P could be plus or minus 2 or plus or minus I. And again, that's 4 solutions. All right, let's take a look at the next page. All right, on this page, we're looking at word problems that lead to quadratic equations. So finding work time. So work and time kind of work together. If I'm saying, for example, that I spent 5 hours on an assignment, then I did one assignment in 5 hours. That's the relationship between work and time. So let's read example 4. Together, an experienced word processor and an apprentice word processor can create a Word document in 6 hours. Together, they created it in 6 hours. Alone, the experienced word processor can create the document 2 hours faster than the apprentice. 2 hours faster than the apprentice. Find the time in which each person can create the Word document alone. So what I'm going to do is I'm going to come down here and I'm going to say we have 3 different scenarios. We have the experienced, I'm going to say that's EXP, experienced. We have the apprentice, APP. And then we have together. Okay, so together the time is 6 hours. This is the amount of time. And this is how many jobs can they complete in 1 hour. So if together they completed 1 job in 6 hours, then they can complete 1 job, let's say 1 job per 6 hours, right? So the number of jobs that they complete 1/6 of the job in 1 hour. Okay, now let's look at the experienced and the apprentice. Alone, the experienced word processor can create the document 2 hours faster than the apprentice. So what do we know nothing about? We don't know anything about how long it takes the apprentice. So I'm going to say X is the time it takes the apprentice. So that goes here. And then how long does it take the experienced word processor? 2 hours faster, so it takes him 2 hours less. So that'd be X minus 2. So how many jobs can the apprentice complete in 1 hour? Well, if it takes him X hours, then he can complete 1/X jobs in an hour. And then similarly for the experienced, he can complete the whole job in X minus 2 hours. So he can complete 1/X minus 2 job per hour. Okay, why do we care? Well, we care because if the experienced word processor completes 1/X minus 2 jobs in an hour, and the apprentice completes 1/X jobs in an hour, then together they should complete 1/6 jobs in an hour. Now we can't say that's true for time. So think about if you say I can complete, let's just say I can clean my room in an hour, and my friend I can clean my room in an hour, and my friend can clean her room in an hour. Together, it doesn't take us 2 hours, it should take less time. So that's why changing it into this form of how many jobs you can complete in an hour helps us set up the equation. So our equation then becomes 1/X minus 2 plus 1/X equals 1/6. And then we're going to use some of those tactics from chapter 6. So again, I have to find the LCD, which I have X minus 2, I have a factor of X, and I have a factor of 6. And then I'm going to multiply through the LCD to each term. Okay, so when we distribute the LCD, in the first term, the X minus 2 will cancel, so we'll be left with 1 times X times 6. In the second term, the X will cancel, so we'll be left with X minus 2 times 6. And in the last term, the 6 cancels, so we have X minus 2 times X. So we have 6X plus, distributing the 6, 6X minus 12 equals, distributing the X squared minus 2X. Now in order to solve this, we need to set it equal to 0, so collecting all the like terms. So I'm going to minus 12X, because I have a 6X and another 6X, plus 12 minus 12X plus 12. 0 equals X squared minus 14X plus 12. Okay, now from here I could try factoring. It's not going to work because I have no numbers that multiply to 12 and add to 14. So we can use a quadratic formula. A is 1, B is negative 14, and C is 12. X equals, I'm going to skip writing out the formula. Hopefully you have it memorized by now. So the opposite of B, 14 plus or minus the square root of 14 squared, which is 196, minus 4 times 1 times 12, which is 98. Let me double check that. Sorry, 48. Okay, so then divided by 2 times 1 equals 14 plus or minus the square root of 148 divided by 2, which 14 divided by 2 is 7, plus or minus, let's see if 148 factors. 148 factors into 4 times 37. So I have 2 times the square root of 37 divided by 2, which is 7, plus or minus the square root of 37. Okay, so now I'm going to come over here and I'm going to say, well, what does that mean? So if I have 7 plus the square root of 37 equals, in the calculator, 7 plus the square root of 37, 13.08, and 7 minus the square root of 37, which would be 0.92. Okay, well, could it take the apprentice 0.92 hours? No, because the experienced word processor takes 2 hours less, so it can't take him less than 2 hours. So then this must be the apprentice speed. This is in 13.8x was in time, so hours. And then, so that's apprentice, 13.08 hours, and experienced would take 2 hours less than that, so 11.08 hours. And you could round to a whole number, 13 and 11 hours. All right. And then the last one that we're going to look at here is distance, rate, and time. So finding driving speeds. Okay, so we have two places, Beach and Fargo, that are 400 miles apart. Just for my benefit, I like to draw a picture. Here's Beach, here's Fargo, and I know that the distance between them is 400 miles. A salesperson travels from Fargo to Beach one day at a certain speed. She returns to Fargo the next day and drives 10 miles per hour faster. So from Beach back to Fargo the next day faster. Her total travel time was 14 and 2/3 hours. Find her speed to Beach and the return speed to Fargo. Okay, this is a distance, rate, and time problem. So I always set up distance equals rate times time. And then I'm going to set up my 2 trips. And I'm probably actually going to need a little bit more space than that. Maybe something more like this. Okay. So my first trip is from Fargo to Beach. So I'm just going to say Fargo to Beach, and then the second trip is from Beach to Fargo. Distance, well, we know the distance between them is 400 miles. So that's pretty easy to fill in there. Okay, and then the rate. Well, that's what we don't know, right? Now there's no wind and there's no river current or anything happening. It's just the speed of the car. Okay, so what do we know about the speed? Well, she travels from Fargo to Beach at a certain speed. We don't know what that speed is. Let's call it X. X, speed from Fargo to Beach. So that means that's my rate that's going to go here. She returns to Fargo the next day and drives 10 miles per hour faster. So her rate is faster. It's going to be x plus 10. Okay. Her travel time was a total of 14 and 2/3 hours. So if I take her time here, we'll call it time 1 and time 2. I know that her total time 1 plus time 2, is 14 and 2/3 hours. Okay, but how do I find time 1 and time 2? Well, I know that distance is rate times time. So if distance is rate times time, then I can find time by dividing by the rate. So time is distance over rate. So using already what I filled in the table, I can say that time is going to be 400 over x, and time here is 400 over x plus 10, which means when I'm setting up my equation here, I have 400 over x plus 400 over x plus 10 equals 14 and 2/3. Okay, now when I'm looking at these numbers, I notice 14 and 2/3 is a mixed number. It's kind of hard to do calculations with a mixed number because you have a whole part and a fraction part. So let's go ahead and change that into an improper fraction. So the left side is not changing, but the right side, I'll do 14 times 3 plus 2, which I get 44/3. Okay, from here we're going to use the same tactics that we've been doing. We saw them in chapter 5, I think, and chapter 6, and then we've kind of seen them throughout chapter 7 and chapter 8. So I'm going to leave this one for you to finish. That's your homework. Okay, I'm not putting up a math Excel also, so I want you to focus on understanding these notes, especially these last 2 word problems, okay? And then finish example 7, and I will go over the answer and sign off that you finished it next class.